In this section, we will be looking at a couple examples of statistical software that you might use to do basic and more advanced statistical analysis or work with your data. So I'm going to be pointing out some general things about manipulating data using Excel first of all, and then we'll be looking at using SPSS to conduct some of the analyses that we've been talking about. This is a blank Excel worksheet here, and I'm assuming probably most of you have worked with Excel before and are familiar with the with how it works. So I'm not going to spend too much time, but just in case any of you have never seen one before, this is what it looks like, and let's look at how it works if you wanted to enter some data. So let's say we had a small data set of some students in a class, and we wanted to do some analysis of the data. So let's say we wanted to just identify the students by some number, and we were interested in looking at their gender and their score on some test. All right, so we have three variables, and we'll put those right along the top there as labels for the variables. And then let's say we have decided that gender will be identified in terms of a 1 for males and a 2 for females. That's a fairly typical way of doing it. You can do it however you want, but the key idea is to do it in a way that you will remember which number means which. So let's fill in some random data here. So let's say we have a couple of males and a female, a couple more males, and then a few more females. I get to about 15 students there. And let's make up some scores here. Let's say it's a 20-point exam, and this person scored 17, 13. There we go. And then I want to fill in the class number. I will just call it student 1, student 2. And I'm going to use the fill function to complete the rest of the class numbers. So I'm going to highlight the area and click on the fill here button, and I'm going to fill in a series with a step value of 1. So that means I'm telling the Excel to continue the list I started, adding 1 to each number as you go down, and highlighted all the way down to the 15 students, so it should fill in for us like that. So that's a handy way of doing that. So again, I'm assuming you all have a lot of familiarity with Excel. I just wanted to show you a couple of descriptive statistics that you might want to do. So let's say we are interested in finding out, for example, the average score for the students in the class on this exam. Then we would highlight the cell where we wanted the average to be placed. So I've clicked it on the cell right there at the bottom of the row of scores, and then I'm going to click on the I'm in the formulas menu, and I'm going to click on insert function and average. Click on that and say OK, and then it's going to give me a range of numbers here, but I'm going to go ahead and highlight the ones I want just in case it's not right. It looks like it is. C2 through C16, and OK. And that will give you the average, which is 16.73. So the average for this group of scores, the mean is 16.73. Let's say I also need the standard deviation. You can do that too with Excel. So we'll click on STDEV, standard deviation. We'll say OK, and we'll go ahead and highlight the cells that we want the standard deviation for again, and we'll click on OK. And so now we have a mean and a standard deviation for this group of scores. All right. What else can we look at with Excel? Another thing that is handy sometimes is to know the highest and the lowest score. So you can do max and min. Highlight the scores there. And now I know the maximum score was 20, and I want to know the minimum score. So again, I'll identify the cell where I want that to appear, and that's MIN. We'll say OK, and we will highlight the scores one more time, and we'll say OK to that. And that tells us that the minimum score was 13. So now we have the range was between 13 and 20. So calculate quite a few functions using Excel. It's also possible to calculate a variety of the other statistics that we talk about, for example, t-tests and a few others, but personally I prefer and find it easier to do that using the SPSS software. So we will actually use the SPSS to look at some of those other variables that we looked at. But one that we will look at here, and I'm going to show you another database that I've already filled in with more data to do it, is this one here. So here I have a data set with the populated with data for 4950 people. So I have a number of variables identified here: gender, age, ethnicity, marital status, education, employment, and so on. I have quite a few because we're going to use this data set to do some analyses. But one that's fairly easy to do on Excel that we have talked about is the correlation, calculating a correlation coefficient. So to do that, again, you begin by highlighting the cell where you want the correlation coefficient to populate. So for this set of data, let's say I wanted to calculate correlation between age in years and a variable over here that I know represents physical functioning. That's the MSIS phys right there. So get my own labels. I know what they mean. It refers to a score on an instrument that measures the degree of physical impact a condition is having on the person. So we will correlate physical impact with age in years because we're interested in seeing whether there's a relationship. So we will highlight in order to calculate a correlation coefficient. We'll highlight the cell that we want to have populated with the correlation coefficient. We'll go ahead and put it there, and then we'll do insert function. Click on that, and there's Pearson product moment correlation. We'll go ahead and choose that one. To do a Pearson, we'll click on OK, and it will ask us for the two sets of data that we want to correlate. So we'll go ahead and highlight first of all age in years. So we'll highlight that column, just the numbers there, and then I'll click on array 2, and we'll go over to the other data that we want to correlate, and that was this one here, MSIS phys. That's physical impact. We'll select that column. So we've got B2 through B50, M2 through M50, and we'll say OK. Let's see if there's what the level of correlation is. So we have about 0.136 R. So the R, the correlation between age and years and physical impact on physical functioning, is quite low in this sample. That's how you would calculate the correlation coefficient. So those were the sorts of things I wanted to show you in Excel. There are a lot of other functions that you can calculate, as I said. let's go ahead and look now at using the other statistical software that I wanted to spend a bit more time with, which is the SPSS. What we're going to do is transfer this data that we have in Excel to SPSS and show you how to do that. So we are going to first of all just go ahead and select just the data points in this data set, and so we're going to select data and we're going to copy it. So we're going to go to Home and Copy. Now we will open up a new SPSS worksheet. So here's our SPSS worksheet. Looks somewhat similar to the Excel, and we're just going to paste in that data that we collected in the Excel. So we're going to click on Edit and Paste, and it goes ahead and pastes in all that data that we just copied from the Excel worksheet. Now notice we have to identify the names of these variables. We don't know what these variables are called, and that's going to be confusing. So we would go, the way I would do this is go back to my Excel worksheet where I have all the labels, and I would copy them, and then maybe open up a new worksheet, but I want some clear space here, and I would do a paste special, click on paste special, and then I would click on transpose. And what transpose does is shifts the order, so instead of going across the worksheet, the data now go down the worksheet. So it transposed the order in which the data were listed. And the reason I do that now to transfer to SPSS, rather than having to type all of these in, I'm just going to copy them again. So copy, go back to my SPSS worksheet, and I'm going to click here at the bottom where it says variable view. Right now I'm in data view, but I want to have variable view. Click on that, and I can just select this column and edit, paste, and there are my variables. Alright. The other thing you have to do when you're using SPSS is make sure that the SPSS knows what type of data you are working with, and you have to actually identify what type of variable you're working with. So these are all numeric variables, but are they categorical, or are they measured on a interval or ratio scale, or are they nominal variables? That's what we need to tell SPSS and fill in there. So for example, age in years, let's do that one. Age in years is measured on a scale. Ethnicity and gender are both examples of variables measured with a nominal variable. So those two are going to both be, measured with a nominal scale. So those will both be nominal. Okay, and you would go on down and fill those in. And I have one where I've already taken care of that, so I'm actually going to bring that one up now. So here's our data with the type of scale that we're using already filled in here. So I've gone in and filled in all the correct scales of measurement there, and also filled in what the what the values mean, so I can remember that in the future. So now we have our data filled in on the SPSS worksheet, and we're going to look at how we use SPSS to do some of these statistics that we've been talking about. So let's start with some descriptive statistics. And to do descriptive statistics, we're going to come up here to the Analyze menu, and you can see the various statistical analyses that we can do are all listed here, but we're going to begin with descriptive statistics, and several options here. We'll go ahead and click on descriptives because we want some means and standard deviations, maybe range, minimum, maximum, a variety of things. You can do variance. You have a number of options there. So we've selected a few of those: mean, standard deviation, range, minimum, and maximum. Continue. And now we want to enter the variables that we want to get these statistics for. So let's just throw some in here. We'll do age in years, gender, how many hours per week a person is working, income. Let's do those physical impact score, and this is life satisfaction. Go ahead and throw that in just for some different examples. And this is the output that will pop up, and so you can see for gender, notice that for gender, which is a nominal variable, the descriptive statistics are going to be fairly meaningless in terms of things like mean and standard deviation, because it was either 1 or 2, but the rest of these might be valuable and useful for us. For example, the mean age, standard deviation in age, the maximum age is 79 years, minimum 28, and it tells us that the range, it does that subtraction for us, it tells us the range is 51 years. So what about those nominal variables? Let's say we are interested in getting some information about them. We could go again to Analyze, and this time under Descriptive Statistics, instead of descriptives, we would look at frequencies, because this time we're interested in some information on these nominal variables, or even some of the ordinal variables. So let's do income level there, gender, ethnicity, and income. And we'll click on Statistics, say what we want to look at here. Again, these are descriptive statistics, so if you have variables for which that would be meaningful, you can go ahead and select those. We'll just do mode because I think there's 1 or 2 where mode might be useful. Continue. You also have the option of creating bar charts, pie charts, or histograms, which tell you about the distribution. Show you the distribution, but that wouldn't be meaningful on these nominal variables. We'll go ahead and do some bar charts, and then we'll click on OK, and let's see what frequencies show you. So we'll bring up in the frequency tables. So frequency will tell you the number of people in each category. So there are 9 males, 39 females in this sample, and it will tell you the percentage of people in each group. So you'll notice that there's one person who didn't report a gender, so that is identified as missing. And then the percentage is the percentage for the whole sample, including that one person who's missing. But if you want to exclude any missing variables and find the valid percentage, so that would be the percentage of males among all the people who reported a gender, you would get 18.8% male, and the sample is 81.3% female. Alright, so it will tell you those different things for categorical or nominal variables here. and then it will provide the bar charts, as you can see. So that's sometimes handy when you want to include some graphics in your report. You can just select and copy and paste these bar charts into your document. So that's the descriptive and frequency statistics. Let's look at what else we might want to do. Let's say we want to look at some correlations. So I went to the Analyze menu and down here, Correlate, and it gives you some different options, but we'll do a bivariate correlation. Click on that, and let's go ahead and select again some variables measured on a interval or ratio scale. So some scale variables. Let's do hours worked per week, age in years. Let's see, life satisfaction score, and physical impact again. Let's look at these and see how well these correlate. Now you have the option of selecting the Pearson product moment correlation. And we'll go ahead and do that one because we're looking at some variables that are measured on an appropriate scale for the Pearson. But if we were interested in some correlations for variables measured on ordinal scale, for example, then you might also click the Spearman or the Kendall's tau, which would be more appropriate for correlations based on ordinal variables. But we have scale variables, and go ahead and say OK, and let's look at the correlations. So look at the correlations of these different variables. You'll get a correlation table like this. It will provide the Pearson product moment correlations between the variables. It will identify the significance of the correlation, whether the correlation is significant or not, and the n, the number of people included in the analysis. So let's see if we have any significant correlations. And it looks like in this row, at the 0.05 level, only this correlation, 0.005, is significant, and it's between age in years and the number of hours worked per week. And it looks like, you notice, this correlation is actually negative. So that means that as the age in years goes up, the number of hours worked in a week goes down. And it's a correlation of R equals 0.403. So we would say that's a moderate negative correlation. All right, let's look now at a couple of those tests of difference. So let's do an independent samples t-test, and then maybe we'll also look at an one-way analysis of variance just to show you how that would work. Again, you won't be required to do these for this course, but just so you're aware of the process, we are in the Analyze menu, we're in the Compare Means, and we're going to select an independent samples t-test. And notice you have those other options that we talked about for t-test, but we'll go ahead and do an independent samples t-test. And it looks like I already have calculated this one for looking at whether a person is employed or not. So I entered employed or not, and it will ask you to define the groups when you enter that variable. It has been entered as either a 1 or a 0, 1 for employed and 0 for the person is not employed. So you enter that, and then you enter the test variables that you're interested in comparing between these two groups of people who are employed, people who are not employed. And so we entered the physical and psychological impact scale scores, life satisfaction, and age in years. So we're interested in seeing if there are significant differences between these groups based on whether they are employed or not. So we'll go ahead and say OK, and we'll calculate that t-test and look at the results. So the first thing that comes up in the t-test results is this table of statistics, which identifies for the two different groups what the means are. So for example, it looks like there are 11 people who are in the working full or part-time, the employed group, and there are 33 people in the unemployed group. That's the first thing we notice there. And we can look at the means. So for example, for life satisfaction, the mean of people who are working is 35.6, and the mean life satisfaction score for people who are not working is actually higher in this small sample, 37. So there's a difference of 2 points. Is that going to be significant? We'll find out in a minute. In terms of age in years, it looks like there's a bigger difference here between the means for people who are working, with a mean age of 44. So the mean age of people who are employed is 44 years, and the mean age of people who are unemployed is about 12 years older, 57. So you can get that information from that table. Then you will get the independent samples t-test table, and for each of the variables that we entered, it will provide us with information on whether the t was significant. And then over here under the t-test for equality of means, provides the t and the significance of the t-test, whether it is significant or not, the degrees of freedom for the t that was calculated, and then that also tells you the mean difference between the two groups. And it looks like the first analysis we looked at, which was the first two, were based on the impact scales, psychological and physical impact scales, and these tests were both not significant. Life satisfaction, that's the life satisfaction scale there, and again, the difference of 2 points turns out to be not significant. There is a significant difference in this last analysis, though. You can see the significance of level of 0.002. So we have, for age and years, we do have a significant difference between the two groups. The difference of about 12 years between the two groups was significant. So we have a t of negative 3.341, degrees of freedom 42, the significance is 0.002, and so because that is smaller than our alpha of 0.05, we would say that there is a significant difference between the two groups. So that's how you would calculate a independent samples t-test using the SPSS. Let's see if we can do an analysis of variance. And remember, for analysis of variance, you need 2 or more groups involved in the analysis. So again, you will not be required or requested to complete a one-way analysis of variance, and it's actually a more advanced analysis than I would expect you to do for anything in this course. I'm just going to go ahead and show you how you would do it, so you have just enough knowledge to be dangerous here. But just a quick overview of how this might work if you were doing this sort of analysis with this data set. So we will look at life satisfaction, and we need a variable with 2 or more groups. So let's go ahead and look at income as the factor here. So we are looking at whether there are significant differences in life satisfaction scores based on the income groups, and I think there are 5 or 6 income groups in this sample. And then remember, if we do find a significant analysis, then we would need to do post hoc analysis to find out where the differences, significant differences between the groups were. So we'll go ahead and select the Bonferroni post hoc comparison, and we'll set the significance level at 0.05. Continue, and let's see if there are meaningful significant differences in life satisfaction based on income in this sample. So we have the analysis of variance table. Remember, ANOVA we calculate an F statistic, and we see our F, and this analysis is 3.130, and that is based, remember, on that ratio of between groups within groups. Calculated comes to 3.130, and it looks like that is a significant F at the 0.05 level. So we have a significance level of 0.02. So we know that there are some significant differences between the groups, but we don't know where those differences lay until we look at the post hoc analyses. So these comparisons. So we have 1, 2, 3, 4, 5, 6 income level groups. Those making less than $25,000 a year, 25 to 39.9, 40 to 59.9, 60 to 79, 80 to 99, and then over $100,000 a year. And as I said, we know from the F statistic that there are some significant differences, but we have to find them here in our table. And it looks like in the first comparison of less than $25,000 to all the other groups, there are no levels of significance below 0.05. So it's not there. Let's go down to the next one. And here we see a significant comparison, 0.043. So that's lower than the 0.05. So we have a significant difference between two of these groups. And it looks like it is the group making 25 to 40,000 is significantly different than those making over $100,000 a year. So that's where that significant difference lies. It's just between the people making 25 to 40,000 and those making over 100,000. And looking down the rest of the table, I don't see any other significant differences, so that's interesting. Only for this between these two groups that we just identified. It's the only place where a significant difference lays in terms of life satisfaction and income. So that's a quick look at how you might conduct an analysis of variance using SPSS. Let me just highlight that you can also do of course, the various regression analyses that we talked about. So you can conduct multiple regression analyses and binary logistic regression analyses. And then there's one more analysis I wanted to show you using SPSS. And for this one, I'm going to bring up a different data set. This is the data set for our chi-squared analysis that we did when we talked about conducting a chi-square analysis. And remember, we talked about a group of 40 people, 20 of whom had received job placement services and 20 of whom had not. So in this data set, you can see I've labeled those who received job placement as a 1 and those who did not receive job placement as a 0. So 1 received job placement, 0 did not. And then I've also labeled this column as indicating those that are employed at the end of the rehabilitation plan and those that are not. So a 1 represents employed and a 0 represents unemployed. And these are the data that we use to do the chi-square analysis. So let's go ahead and do that and see if we get the same result. So to do the chi-square analysis, we go to descriptive statistics and crosstabs. And remember, we said sometimes chi-square analysis is referred to as crosstabs, and so we have two variables. We'll go ahead and enter one in the column box and the other one in the row box. There's only two variables in each, so it doesn't really matter which is which. And then we will come over here and click on statistics, and we want to do the chi-square. So that's the statistic we want. There are a variety of other options, but we're going to just focus on that one. And then we're going to click on the cells box there, because we want to identify what was observed and what was expected. Continue. And that's about all there is to it for that. And we'll click on OK. So here is the output for our chi-square analysis. We'll look at the table here. And this represents where the data lie. So we look at this table and we see here's the people who received or did not receive job placement. Among the people who received job placement, that would be identified in this column as number 1. 6 were unemployed and 14 were employed at the end of their rehabilitation plan. And among those who did not receive job placement, 14 were unemployed and 6 were employed at the end of their rehabilitation plan. So let's go down and look at the chi-square test then. Note, before we do that, note that in this table we identified the observed and the expected. And you can see the expected count in each box, as we had in our null hypothesis, was 10 in each box. What we observed were the counts, the 14 and the 6 and the 14. So in this table we can see the observed and the expected, but the computer goes ahead and does the analysis for us, comes up with the same answer. Remember, we had 6.4 when we computed our own chi-square, and 1 degree of freedom, and we said that that was significant at the 0.05 level. And here we see that the significance is indeed 0.011, so well below our 0.05 level. So as we found when we calculated the chi-square ourselves, for chi-square of 6.4, we have a significant difference between the groups. And the notes down here will tell you that there are 0 cells that have expected count less than 5. So that was that minimum expected frequency in each box. Remember, you have to have at least 5, and we do have at least 5 in each box, so we're good there. And that is how you would compute a chi-square analysis. So that concludes our brief review of how you can use Excel and SPSS. I encourage you to play around with both of these. They have obviously quite a few other features and things that you can do with them, like use them to make bar graphs, line graphs, and various sorts of other graphs that again can be very useful in representing your data for a research report or a program evaluation report, among other helpful and useful features that make it much easier to manipulate and analyze your data. But those are some of the fundamental analyses that we have looked at and talked about this semester, and how to use SPSS and Excel to compute them.